Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Andrei Bondarev. Andrei works at sourcelabs, a consulting firm, and he's recently built a Ruby client for Weaviate and LangChain. So I think this will be such an interesting podcast, diving into the nuances of AI software consulting with these new waves and deep learning tools like LangChain, Weaviate, and obviously like the LLM APIs and all these things. So Andrei, thank you so much for joining the podcast.
Thank you. Hey, super excited to chat with you today.
Awesome. So could we kick things off with Source Labs and sort of what you're seeing in the kind of consulting space with the new AI tools?
Sure. So I run a small software development firm. It's called Source Labs. So we build custom applications, technology solutions for small, medium, but also large enterprises. So we work with both venture-backed startups. We worked with Y Combinator companies, Techstars, accelerated companies, but also with all the way through Fortune 500 companies.
Wow, that's interesting. I haven't heard too much about so this is kind of like a staff. I've heard of like staffing contracts where people need to build some, like say you need to build a Weaviate database, so you would a startup like a Y Combinator startup would hire these firms to like quickly build the new technology. Can you maybe walk me through more about like what the business of that looks like?
Sure. So we don't. We do some staff augmentation where companies just want to pour more fuel basically on the fire and kind of accelerate the development of their technology or the execution of their technology roadmap. But we also love to do greenfield projects and kind of come in and assess what the problem is, what are the outcome, what are kind of business objectives you're trying to reach, and how to get you there. And we've been this year we've been especially hyper focusing on AI, ML, and LLMs, of course.
Yeah, I'm super excited to dive more into the AI, the new kind of stack that's emerging. But quickly, could you tell me like maybe for entrepreneurs listening to this podcast, like how did you get into this kind of space?
Yeah, so actually, we just finished executing on a large project for a client. I'm not going to disclose who the client is, but it's a well-known public company, and they have a set of tools that they built that provides a data analytics layer on top of public policy, both
Hmm.
national and global, all around the world. So public policy like laws, rules, regulations, etc. And we just concluded a massive project where we rebuilt their whole kind of application, and a large part of it was rebuilding their search engine. And so we built that in Elasticsearch, and we did both the front end, the back end work, the setting up the data pipeline, configuring the indexes, the APIs, etc. And as soon as we finished it late last year, I kind of came to a conclusion that what we had built is essentially kind of outdated now. And this was and as the vector search database has kind of started being very popular in the market, I figured that building a keyword search is as a core feature of your product is no longer very attractive. I mean, when you're building a search experience now, you need to make sure that when a user interacting with your system, your large data sets, that the system also understands the intent, the meaning, and what you call the semantic search. And this kind of led me down the path to explore the current capabilities, the current systems, the vector search databases, and I discovered Weaviate and prototyped a couple kind of pet projects with Weaviate.
Hmm. So I love hearing that background. I've learned so much from like the people at Open Source Connections and that whole community around. And Byron Vorbeck has recently done a talk on from keyword to vector at Berlin Buzzwords, and this kind of evolution of the The way I understand it is that Elasticsearch was quite a massive thing, and a lot of consulting developed around helping people implement that and add keyword search, and now this kind of this shift to vector search. And yeah, I find all that so interesting. I love the mention of the semantic search and fuzzy meaning, intent understanding, all that kind of like abstract stuff. But yeah, so quickly, I think kind of staying on this topic, with your transition into vector search, what was kind of like your eureka moment? Like what got you over there?
Um, Again, some of the products I've prototyped, it seemed like, I didn't, when I'm searching through a large data set, as I mentioned, I no longer have to search for keywords, exact keywords that are found in those data sets, right? I can search for synonyms and similar semantic concepts, right? Similar concepts that are similar in meaning, and get to information that I need. And I've really enjoyed Weaviate. So I've looked at a couple different solutions. I really enjoyed Weaviate. Like I love the module system. So I like how it's an end-to-end solution. Um, and there's a lot less plumbing that you have to do, as opposed to some of the other solutions. And my tool of choice, although I've played with a lot of different languages throughout the years, throughout my career, my tool of choice has always been Ruby. I love the language, I love the ecosystem, and um, kind of my journey into the vector search and the open source work was kicked off by me just writing a Weaviate API client in Ruby.
That's super cool. Really quickly before, obviously, we're going to dive into Ruby, and that's so interested in the client. So it sounds like you're exploring these new tools, and I love the mention of the module system because I think it'll tie so nicely with this as well. As I wanted to then understand how you like came into LangChain and sort of your early thoughts on using that.
Yeah, so obviously, it's not I think the space um, is so young, right? And people are prototyping, and people are doing a lot of prototyping and exploring different approaches. Um, it's not exactly a plug and play just yet, right? So some of the things you need to think about when you're indexing your data into a vector search database is like the context window, for example, right? And how do you determine the perfect context size? How do you split up your data, right? A lot of times you can't just split on a certain character limit threshold, because you kind of lose the semantic boundaries, right? So for example, a lot of times, like when you're searching for an answer, an answer might be a combination of the different chunks of data. So there's that problem. So there's chunking. Um, and also, there's a lot of kind of underlying configuration that needs to be set up when you're configuring the vector search databases, like what kind of embeddings you're using, what kind of formulas you're using, whether it's cosine or dot product, to kind of calculate the similarities.
Mm-hmm. Yeah, I think something like, well, firstly, I think I'm curious about the text chunking things and the solutions to that offered in LangChain. Sort of, I know about like the recursive character splitter that particularly I think like delimiters that are cooked in, like if you're splitting up Python code or stuff like that, or Markdown where it looks for these particular symbols and then just has the 512 tokens. But is there more? And for maybe a little more context, on the Weaviate podcast, we've had Brian Raymond from Unstructured, who's presented this idea of using these like visual document parsing models to maybe extract the structure of like this chunk of text as an image caption. These kind of things, like what are kind of the innovations in text chunking that you're seeing?
Yeah, so You can actually, so one approach I've seen, and I think folks are coming up with new approaches weekly. One approach I've seen is where you would actually feed some data to an LLM and ask and prompt it to suggest the chunks based on the meaning that that body of text represents.
Mhm.
Um, Also, one approach that we're exploring within the project that we're going to talk about shortly, Langchainrb, is actually splitting up on a custom function. So, for example, passing a lambda, passing a function, and then writing your logic
Mhm.
uh, that would split the text. Um, when it's being parsed, right? So one example I'll give you is, for example, if you're importing a legal document, right, and it has several different provisions, intellectual property, non-compete, terms of service, etc. So, for example, uh, you probably want to split that document by those specific sections,
Mhm.
and it's not you can't configure a set character chunk. But you could say that as the text is being parsed, right, if you encounter this string, which is an enumerated heading of that contract section, then slice it, right? So that's another approach.
Yeah, I think we get lucky with like web pages where you'd have like that, like angular brackets slash ul to say we're at the end of a list, and then
Right,
like don't split this list into two separate chunks for embeddings. But yeah, as you mentioned, just kind of detecting like that kind of shift from free text, like if it's like laws and it starts like the title of a new law, and so and the chunk, even if it was only 100 tokens, and it's not just like a 500 token window. And so yeah, super interesting. And I think one more
right.
topic on LangChain. I think actually it makes sense to kind of cover this before coming into the Ruby ecosystem, particularly is so with LangChain. You mentioned the configuration of the embedding models, the configuration of the vector databases. My understanding is you're seeing the value of a framework like LangChain as it lets you rotate out those kind of things. It's like I don't know what a good word for that is, but it's the orchestration behind, okay, Cohere has a new embedding model, so
Hmm.
switched out with OpenAI's, or, Weaviate, want to tweak something, or so could you tell me more about how you see that?
Yeah, so I think there's a lot of benefit about using an opinionated framework, right? And actually, again, we're going to get to the Ruby world shortly. A large part of Ruby development is Ruby on Rails, right? So
Mm.
building web applications, APIs, in a extremely opinionated framework, right? And that's why and how it took off and became so popular, because you didn't have to think about all these low level decisions, right? The whole approach was that, hey, we think this is the best way to build 95% of the web applications. It covers 95% of use cases. It fits 95% of the use cases. Uh, and this is the opinionated framework that I think would work really well. So I'm drawing a parallel to building LLM based applications, is that I think developers can also benefit from this opinionated approach.
Yeah, I think that's the in our podcast on LLM agents. Colin Harmon was describing this idea with like semantic kernel and how it's a little bit more like decided on. These are the abstractions, and rather like whereas contrastively a LLM framework like LangChain is a little more open ended, where it's a little more open source community driven, less of a rigid consolidation of these are the tools to use. It's more the discovering. Yeah, I think that whole thing is a really interesting. Just thinking about like what is a software framework generally as like kind of a market category, what kind of thing does it strive to do? found that learning about that is all really interesting. Super cool. So I think it would be great to dive into Ruby, and I'll try my best to keep
Great.
up. I know a little bit.
Yeah, so as I've mentioned, Ruby has been a tool of choice of mine for a very long time. I've tried lots of different languages and kept coming back to Ruby. Um, a lot of people talk about developer happiness. Um, and I will also mention that it's always important to use the right tool for the job. And I found that the problems that I was solving, that Ruby was great at solving those problems. And so Ruby is still very popular. There's still a lot of companies all around the world using Ruby. They're supporting, maintaining existing products. They're starting and building brand new applications with Ruby. Obviously, Ruby on Rails is huge within the Ruby community. So I thought that as a Ruby community, we ought to have a solution for building LLM based applications because as this AI wave has been kind of rolling in, I think product managers are coming to their engineering teams now and are asking, hey, we're aware of these capabilities. We'd like to add some of these capabilities to our existing products. Here's a business case for it. How can we accomplish this, right? And then as engineering leadership, team leads, architects, they have to decide whether you add Python, right, as kind of the most popular language within that space in the mix. And if you do that, you're spinning up additional containers, additional compute, separate services, right? You have to figure out whether you want to support additional complexity, additional overhead, and also whether you have capabilities on staff to do that. Or if it's a Ruby shop, whether you'd like to use a solution that your engineers would be familiar with, right? And I think there's also, and this is a larger conversation. I think there's also kind of people are reflecting on all of these complicated microservices architectures now. This path that we as the software development community have gone down. People are looking at all that complexity and are thinking twice now before doing that. So I see a lot of people kind of consolidating their architectures into a monolith application architecture because it's a lot of times it's a lot easier to manage.
So taking it apart a bit, because I don't understand this too well. So a microservice architecture is where you like containerize every function and turn it into like an API, and then the system interacts with it that way. And then that way, if something's in Python, it's just a container with an API. So it's like whatever, compared to where a monolith where the whole thing is in Ruby. So you put it in and it's all one application.
Right. Another way to think about it is the microservices architecture is when different parts of your application are strung together by network boundary, basically have network boundaries, right? So from one component of your application to talk to another component of your application, there needs to be a network call, right? And HTTP request, for example, over the wire. Whereas a monolith application is where a monolith architecture is where different parts of your application, different components of it are hosted within a single within a single kind of memory unit.
So then, where with my deep learning hat on, I'm thinking about like model inference serving. And so are you able to, I know that like I know a little bit about like bindings where you could, like you can have the inference in C++ and it can have Python bindings to it. Can you do that kind of thing to run inference of a deep learning model within Ruby so that the inference lives in the same application?
Um, so any of those libraries where Python wraps underlying C functions, uh, you can theoretically rewrite those same libraries in Ruby, and call into those same C libraries. Um, does it make sense to do that? You'd have to think really carefully about that.
Yeah, it's so interesting. I mean, I guess I'm just thinking about like I guess like some things with Weaviate, it's like I think about if we could have like a model inference directly in the database compared to doing networking requests. Like if we would want to just like to throw out an example, like if we wanted to do this kind of like re-indexing idea where you have a model and now you fine tune it and you have a new model and you want to update the vector space, like if we could do that inference directly in Weaviate, that's what kind of motivates me asking this question about like when you would build in model inference into some kind of software architecture compared to like API requests across the wire. And I guess it's like where my head's at with that kind of thinking. But pivoting topics a bit, I'm really curious about like clients in general, like a Ruby client on top of a database. How do you think about like database clients?
Um, well, so for example, if we take Weaviate, right? So you guys currently have a REST endpoint, an HTTP REST endpoint, um, and a um, for schema management, also indexing, um, and largely the capabilities for querying the database are there's a GraphQL layer in front of
Mhm.
it. Um, and I don't personally find GraphQL to be super convenient in terms of constructing queries. I think JSON just feels a lot more intuitive, but also um, more in line with kind of the data structures um, that are native to different programming languages. Um, so actually, and that's exactly the reason why I initially wrote the Weaviate Ruby API client, is to abstract away some of those complexities, like communicating with the GraphQL client. Um,
Mm. So because like I know with Python, it's like you get back the request, then you parse it where you're like, data get. So like you instead of having to unpack the JSON that comes back from the GraphQL, you already kind of parse it out, and then you just create like a syntactically nicer kind of interface to the database. Is that generally the idea?
right, right, correct.
So I think the other topic is, I understand very little about this. Eddie explained it to me, and I just kind of nodded along in the podcast. Like this difference between like GraphQL, REST API, gRPC APIs, like what is really the difference? I just kind of, for me, I just think about it as like what the input output looks like.
Yeah, so it's basically different communication protocols. So gRPC, there's a couple different frameworks. Um, I'm personally most familiar with Apache Thrift, um, and it's it's um, it's quite flexible. You can configure your transport layer to send data in lots of different formats, binary, JSON, etc. I've found that it's a little bit challenging to debug, actually, um, and it's also there's also an overhead in maintaining it, because basically the way it works is kind of the API server, the API host declares an interface, and then you compile that interface into um, client libraries. And so you need to make sure that all of the clients that communicate uh, with that server have the latest version of those client libraries. So there's a little bit overhead in terms of making sure that all of those client libraries are synced.
Hmm.
But there's also benefits to using a gRPC to string services together. I think the obviously the most common way of stringing services together is still HTTP, JSON APIs, and I find that to be most convenient to kind of program against.
Hmm. Maybe just like a quick thing out of, I know extremely little, is there more opportunity to kind of innovate on that with respect to like, because I've heard about like streaming technologies. I also don't really know too much about what is under the hood, but from the perspective of, like vector database, you're trying to send your data to this embeddings inference API as fast as possible and get the vectors back, or, say you're sending prompts and you're getting the response back from the large language models. Is there like a lot of opportunity to kind of interface on how you do that networking?
In terms of streaming data from vector search databases?
I suppose just I'm broadly asking about the technology, the whole entire networking technology category, and if this particular how we're currently thinking about how APIs provide the deep learning embedding and then language model inference services, if that is already as optimized as it can be, or if there's room for
Mm.
that.
Yeah, that's a good question. I know the large language models, a lot of them. I know OpenAI does this. You can stream completions, right? You can
Mhm.
stream a chat completion, and so it's sending you tokens as it's producing them. Um, uh, Within our open source project, we've added support for a bunch of other LLMs. So, for example, we support Google Palm. I haven't seen streaming capabilities within Google Palm yet, although they should definitely add that. So I think the LLMs themselves are pretty optimized. Obviously, when you're adding a lot of data, to a vector search database, I think there's an opportunity to stream that data as it's being indexed. Um, but I'm not sure what's some of the other kind of opportunities are.
Yeah, it's really just, I think that whole category of model inference, just all the software behind it, whether you're doing the Onyx optimizations of the model, or like the Triton servers, neural magic is interesting, or say you step into like the distributed computation area where you have like Ray and Spark, and I think there's so much to that kind of topic. Yeah, so kind of coming out of this topic a bit, I think it would be really interesting to just kind of talk about, to transition back into just the meta around the evolving software space. Can you talk about like your experience in software and how that's changed with the latest breakthroughs in large language models and vector databases?
Um, yeah. So one um, really big use case that also I've referred to earlier is obviously search experiences, right? So um, building a keyword search is no longer adequate. Um, so I think we ought to offer in a lot more kind of extensive elaborate search experiences, right? So semantic search.
Mhm.
Um, Chatbots are obviously becoming extremely popular. So there's a lot of things and workflows that could be, and business processes that could be automated there with software, um, and also um, yeah, doing Q&A over your data sets. So, for example, in our LangChain RB project, we've built an agent that does a text to SQL search. Um, so previously, there's a whole set of tools that data analysts used, right, to make kind of interfacing with underlying databases much easier. Um, and I think these LLM-based capabilities make it even more so convenient to do that.
Yeah, I love that you brought up the text to SQL thing. It's so interesting to me, like, just seeing the trend in, like, like social, like entrepreneurs on social media. Like, I remember, there'd be a lot of like, here's how I started my social media agency. I was like, I make 20K a month at 17 with my social media agency, and it'd be, and it's like, oh, I help businesses like run their Twitter, Instagram, and that kind of thing. And recently, I've been seeing on, on YouTube with this kind of thing is like, oh, I'm 19 years old. I make 100K a month with my with my AI automation agency, and this kind of like chatbot and is like the skills that you need to build these kind of systems are becoming so different. Like, are it's like no code is finally like really a super serious thing. Do you think like and I think this is a topic that I think about like all the time, is this kind of like zero shot AI where you don't need to train it at all, and so you just kind of plug it in, and you can be 19 years old and set this up. Like, do you think like that kind of thing of like training the models compared to just sort of plugging in these zero shot LLMs, zero shot embedding models, setting it up that way? What's your current stance on that?
Um, well, I think so first of all, I am always a little bit I'm always a little bit skeptical of those YouTube influencers
Yeah.
that claim to make 100K a month. So, but back to your question, I think you have to push off of your product requirements in business use cases. Um, so there's a lot of times where a generic, they call them foundational models, right?
Mhm.
There's a lot of times where a foundational model is either an overkill, um, and really you could just get away with a simpler model doing basic classification task. Um, So there's a lot of times where a foundational model is either an overkill, or it's not best suited to uh, to accomplish the things you'd like to accomplish. Um, so the answer is it really depends.
Yeah, I mean, again, referencing the Unstructured podcast with Brian Raymond, he discussed building a foundation model for visual document information extraction, and it was such an interesting idea. I hadn't considered this idea of like task specific foundation models, but it may like I'd always kind of thought of this idea where you have this algorithm called knowledge distillation, whereas like you use the large model to label data to then train the smaller model, is optimized on that data. And the key idea is, instead of humans labeling data where you have like a one hot vector label distribution that you optimize towards, you have this like soft distribution over the class labels. So, it's like 0.97, 0.001. It like produces this distribution that lets you distill the model. But so like that's kind of the technical algorithm behind like compressing the models. And then, but just I guess we're seeing this take off where it's like, regardless of how that model is produced, like what I'm saying is maybe it's, GPT-4 distilled into the visual document compared to where you just train that visual document thing from scratch and then you serve it. And like, do you think that could also be an emerging startup category? Is like foundation model for, I don't know, I guess it's not that creative, but like some particular thing, like maybe it's like visual question answering has its own its own foundation model. It's not GPT-4 and then it's smaller or something like that.
Yeah, no, absolutely, absolutely. And there's a lot of companies that are trying to do exactly that, and offer task uh, offer APIs that are specific for specific tasks, right? So whether it's summarization, whether it's editing, whether it's paraphrasing, whether it's chat, um, and yeah, I think there's a lot of opportunity there.
Yeah, I just remember this as I passed the mic back. I was in Berkeley 2 weekends ago and I saw these researchers working on this language model called Gorilla. And so Gorilla is like a large language model optimized for tool use. And like, so I think especially as the creator of Langchainrb, I think this would be a great topic is like, how do you see tool use? Like just this whole topic of LLMs
Mhm.
using tools and how open-ended that seems to be.
Yeah, so when we talk about tools, we're also talking about agents, right? And I I believe that the current consensus is that the current agents, for kind of general problem solving, are not very powerful, right? So there's emerging techniques, um, but the current conceptualization of agents and the current techniques and the way they currently work, they're not super useful. So obviously there's chain of thought. There's
Mhm.
so for example in Langchainrb we have a React agent. Um, um, there was another research that came out. There's another research paper that came out recently called Tree of Thought, which is which is kind of an evolution on top of the chain of thought technique. Um, and an agent coupled with tools is basically exactly what kind of OpenAI offers with its plugins. Um, but I'm not sure I'm not sure that the uh, I'm not sure that the agents are super useful just yet.
Hmm. Okay, a lot of that I want to unpack. I want to start with okay, so definitely coming back to OpenAI, the plugins, and now we have this new functions API, and that's so interesting. Then the, hot
Sorry,
take.
I meant the functions. Yeah.
Oh, I think both those things are, I think that's just that whole thing. And seeing how OpenAI themselves are clearly like exploring it as well. It's like a whole, I think this is one of the, evolving things. But so I quickly want to come back to that reference of building it in Ruby. So when I think of tools, I think of like, it uses like a calculator or it uses a
Hmm.
code executor. So like, and then we talked about monolithic architecture versus microservice architecture. I think of these tools as like a microservice architecture, correct? Like where, the email API, the, calendar,
Hmm.
these are
Hmm.
all like API. So would you cook these tools to access into Ruby? So like the implementation of a calculator, is stuff like
Hmm.
that. Is
Hmm.
that, I don't know if I have the great example right now, but maybe you
Yeah.
do.
Yeah. Well, so one example that's mentioned in the LangChainRB's README is this uh, example of prompting an LLM a prompt using the React agent to calculate the distance between New York City and DC, uh, in the number of full length soccer fields, right?
Mhm.
And so And so the way, and so you're asking an LLM to break down the steps and generate a set of actions, right? So reasoning and act, um, generate a set of actions and action inputs that it would need in order to arrive to the answer, right? And so it might say that the first action that it needs to do is calculate the distance between New York City and DC in miles, right? And so if you expose it a tool to be able to do that, right, it will try to use that tool, right? And so you obviously have to execute that tool in the code directly, right? So you would call the Google Maps API and ask it to send it back the distance between DC and New York City, right? You would then take that observation, that result, and send it back to the LLM and ask it for the next step, right? And so it would say, well, now I need to know what the length of a full-size soccer field is, right? So you would call some sort of service that could give you an answer to that question. You will then take that result, package it as an observation, send it back to the LLM, right? So now it has two pieces of data, right? And now it just basically needs to, take the overall distance and divide it by the length of a soccer field to calculate the total number of fields needed, right, to cover a distance. So that's an example of tool usage.
Yeah, I think what you're saying is inspiring. Something I've been thinking about as well with Golang. So Weaviate's written in Golang, and Golang is really good at handling concurrency control with a ton of these parallel API requests. And like one thing that's built into Weaviate has the generative search modules, with which what they do is they take, say you search a query and then you have let's say 20 search results and you want to send each one in parallel to the OpenAI API. It's really good at synchronizing all those requests. And I think I don't have a super concrete example yet, but as you mentioned, the kind of like self-ask prompting and question decomposition, I suspect that there is something to like when to lock these asynchronous kind of API requests, and you lock the shared resource so that you don't overwrite it. And so I do think that kind of orchestration, there is a lot to that. And I think using languages like Golang, and I don't know what Ruby has with that kind of, maybe you could talk more about Ruby and how it handles concurrency and that kind of thing. And or if it does, I don't know too much.
Yeah, I mean, short answer is a lot of these high level languages don't handle concurrency all that well. Python, Ruby, it's kind of a similar story. So
Interesting.
Yeah.
Yeah. I mean, I'm definitely not a programming language. I only know like Golang because of the situation in which I came into Weaviate. But yeah. So that whole kind of thing. So maybe we could talk a little more about the orchestration behind, particularly you mentioned the chain of thoughts, tree of thoughts. It sounds like you definitely need to have a lot of, like templating in place to kind of guide the APIs to do that kind of thing. Especially, chain of thought to me is just where you tell it to like break your plan down, and or the self-ask prompting that you just mentioned, where you need to take a question and then say, do you need to decompose this into two questions and so on? Like, how do you build the template around that to constrain it to follow this kind of behavior?
Yeah, so we have output parsers, specifically for to ask for a specific ask the LLM for a specific type of output, right? So if you want to get JSON back, you can supply your JSON schema and say, hey, I want you to fill out this JSON. And we have prompt management, so you can create your own templates. You can fill out the templates. You can create new templates from scratch. You can save them. So we currently support YAML and JSON formats. And we also look at we constantly have our eyes on the emerging research to make sure that our prompts, our templates, are using the best possible techniques, right? And that's what that's kind of the gist of prompt engineering, is being able to construct these concise yet detailed, clear instructions for LLMs to give you the output that you're looking for, right?
Yeah, I love that topic. I think like the discovery of prompts that work well is pretty interesting. I mean, I think like people obviously kind of snicker at that a bit, the idea that it's like engineering to be doing that kind of tweaking, but I think I kind of respect calling it engineering when you're talking about like like the way that the models switch and like GPT-4 might react differently to the prompt than GPT-3 does, or Claude, or MPT 30 billion, so that maybe there's some kind of compatibility to the prompts and the models. Or yeah, so what do you think about
Yeah,
is it engineering? Yeah.
yeah. So I think that's a great question, and I think the fact that we call it engineering um, actually points to our yearning for prompting to be a much more precise discipline, right? I mean, current prompting is kind of a hack, right? Um, because I mean, humans have a hard time communicating with each other, right? And coming to a consensus and problem solving and right, and when you're interfacing with a system in natural language, it's difficult to get it to do exactly what you want it to do, right? And so and so and so I think when we call it engineering, it's because we want it to be much more precise, and which is why there's a growing concern and kind of um, area that people are exploring to evaluate the effectiveness of different prompts, right? So being able to assign different scores to input output sets, right? Um, Also referring back to the whole tree of thought research. So you get a model to produce different intermediary steps, and for each step you ask it to produce different samples, and then you have to rate those different samples, like how likely is this sample to get you to the best possible answer, right? And so there's evaluation, there's kind of prompt evaluation, input output evaluation taking place at different uh, uh, at all the different layers of the stack. And I'm not sure anyone had solved this just yet. Um, but yeah, I think that's why we're referring to it as engineering.
Yeah, I love it. Like with my experience with doing a PhD in machine learning, where you're collecting all these metrics about the experiments, and I think there still is a lot to that. Like how you do the input output evaluation. Deep learning has like a long history and like these benchmarks, like ImageNet classification or like MS Marco information retrieval, where you or like squad question answering, because I think question answering is a good one that people are thinking about when you like think about these kind of things. We have like just collecting examples, and then looking through where it fails and seeing, is there maybe you like visualize the embedding space of all your inputs, and you color it like green and red where it's failing, and then you look, oh, in this distribution particularly it fails, can we do something about that? And that kind of generalization testing thing, with respect to all you're doing is tweaking the prompts instead of like thinking about some whole another algorithm of training. Like I think mostly it's been like, the generalization testing is done to compare two models trained with like massively different efforts, right? Compared to this, where
Yeah.
it's like just two different prompts, and can that have a profound difference in the test suite?
Right, right, right. And this is also an area of concern in application testing, right? So you're testing input and output, and especially if you're not using a 0.0 temperature setting, right? Which means that you're going to get different results, right? And how do you account for all of those different test cases in the application?
Mhm.
Um, so we're and this is one area that we're currently thinking through as we're building out Langchainrb.
Awesome. Well, super cool, Andre. I think this is a really great coverage of these topics. I think kind of a wrapping up question. I'm really curious about sort of maybe the next breakthrough in AI deep learning that would excite you the most. It sounds maybe like you're an agents guy and you want to see the something with agents, or maybe just the LLM inference costs going down. What kind of things excite
Oh, that's that's a good question.
you?
I think I would love to see the open source models catch up to open AI, right? Um, it seems like GPT-4 and OpenAI, they're the leaders in the space right now. And obviously, there's an emerging field of open source models, right? Um, some of them are getting really good. Um, it's also becoming much cheaper and kind of cost effective to run those models locally. So I would love to see open source catch up to some of the commercial offerings, so that we can use much more powerful LLMs and run them locally
Yeah, I
or
think.
on the cloud.
Hmm. Yeah, that topic is, I mean, it's super timely with, as we're recording this podcast, Mosaic ML has just been acquired for $1.3 billion from Databricks. And, super lucky to have had Jonathan Frankel on this Weaviate podcast twice. So, not that the collaboration has to end now or anything, but, we've, been working with the Mosaic ML people. They're super talented. And it makes me think a lot about this open source thing, because I was so excited with the MPT 30 billion, because I was also kind of like thinking like this group of people, I think they're super talented. I think they can do it. They'll create the open source version of, ChatGPT, or drive the cost of it down. All sorts of
Hmm.
interesting things. Do you think if with them going to Databricks, what do you think kind of are the predictions of what they would continue to
Yeah, to be honest, I
do?
as you know, things are moving so rapidly, and there's so many people in the space right now, doing very interesting things. I have not had the opportunity to play around with Mosaic just yet.
Oh, okay. Yeah, I mean, I don't mean to say. I guess like MPT. I mean, there's definitely like a bias towards what the latest thing is, and that changes every single week. Like one week, it's like,
Exactly. Yeah,
yeah,
exactly.
yeah. I mean, I do think Databricks had published. I think their model was called Dolly or something. So I do think it's quite realistic that they just team up and they keep pushing the open source, and that combination would be the horse I would bet on. But I think there's also
Yeah.
like there's like Stability AI has one. I know just like kind of like Vicuna. I think that one comes out of Berkeley. I don't know too much
Yeah,
about the
yeah.
whole.
Replicate has a Vicuna offering as well. We support that within LangChainrb. And actually, um, to kind of bring it back to LangChainrb, um, what we're striving to do with LangChainrb is provide a set of abstractions that software engineers can understand. Um, and have the flexibility to swap out the different LLMs, right?
Mhm.
Whether it's a SaaS offering and you're integrating with an API, whether you're running a Vicuna model locally, we want to make sure that you can easily swap those out, because as you've pointed out, as we all know, the space is moving really rapidly. Um, what this space is going to look like, and who are the leading models, right?
Mhm.
Like in a couple of months, in 3, 6, 9 months from now on, is going to be completely different, right? Um, but we want to make sure that if you're integrating Langchainrb within your stack, and you decide to switch to a more cost-effective model or just a more powerful model down the road, you can easily do that.
Yeah, I think that puts LangChain and Llama Index, these kind of tools, at a really interesting market position, is how they let you rotate out the models as well as the tools. And you might want to think of a model inference as a tool. Like, again, we talked about, you have a foundation model for a super specific thing. And so whether you use GPT-4 to come up with the plan and then it routes it to other model inferences, you think of that as a tool. I think that, that kind of idea. But and then there's also kind of like the data, like the database things. Like, I hear people discuss like how LangChain lets you, ablate the different vector databases, and that makes total sense. Obviously, like if you want to say, you want to use Weaviate, you want to try the whole vector database market. I think it's also really interesting for, you mentioned text to SQL, and Weaviate does have an aggregate API, so it's not like you can't do that thing in Weaviate, but
Yep.
there are particular kind of join operations and relational database stuff. I can imagine you'd want another kind of data tool, as well as say like maybe the graph database stuff has something to offer. So yeah, that whole positioning of it to wrap around these different services, I think that's super interesting.
Right, right. And actually, one maybe question that I would even pose to to you or the rest of the Weaviate folks is that, um, I I like how how you guys structure your schemas, and you can create schemas that pretty much resemble a traditional database, right? You have those different data types that can mirror your database. Um, and I've wondered whether you can actually use Weaviate as your primary database,
Well,
and whether that was the direction that Weaviate is heading down.
yeah, well, I'd say there are the kind of like the efficient data structures for each of the properties, like inverted indexing on categorical properties, or say like building up trees to search through, numeric values. The thing about this that I think is the most interesting is the connection between how you would join tables in a relational database compared to
Mm,
how we think about joining classes in Weaviate, because each class in Weaviate has its own vector index. And so it's like, I think like with a lot of relational database design, you'd separate like the customer and the purchases, and then like the brand, like the supply chain, you separate it
mm,
out into all these
yep.
tables. And then you kind of like join along. And I don't know if you want to send embeddings like back through a graph like that. That like if that kind of thing, just because I think there are a lot of like under the hood optimizations behind how the relational algebra of like when you're joining the table, you have like conditions for joining the tables. So there's like an optimal order to how you join the tables, because like this one reduces the cardinality to like 5,000 versus like 50,000, right? So
Hmm.
I think those kind of optimizations can be made in Weaviate, but it's not something that I personally am super knowledgeable about. But to me, the thing that I think about more is this idea of like, particularly in like the recommendation case, there's examples of like graph neural networks where you like flow embeddings through relations like that, like, user liked product has brand, these kind of things. And so you can like
Yeah.
flow embeddings through a graph. And I think that's where like knowledge graphs are going to merge with vector databases in some kind of interesting way. But yeah,
Mm,
that
hmm.
whole topic of understanding joining tables or classes, that's something that I don't have a great answer for, but I think it's a super interesting topic.
Got it.
Yeah, I mean, what I'm curious about, like, you probably have more experience in databases than I do, honestly. Like, what do you think about kind of like, yeah, like what are the components of an SQL database system that vector databases should make sure to add to make it a one-stop shop for your data?
Um, hmm. That's a very good question. I think um, obviously vector search is such a large, massive, growing space that traditional database vendors are looking to add those capabilities, right? So there's PG Vector, the
Mm-hmm.
Postgres extension, right? Uh, we're aware of some of the other database vendors and adding those capabilities
Yeah.
to their products. Um, and there's kind of pros and cons there. Same way that there's pros and cons to um, having a monolith um, application architecture or a microservices centric application architecture.
Yeah, because isn't there's something to when you compute. There's like indexes that you compute with SQL where you're going to join like 20 tables together. Like you've got like a payroll software, right? And so there would be like a memory overhead to building up those kind of indexes, right? Something
Right.
like that. Yeah. And so the
Yeah.
question then is, I don't know. I think it would probably be a case by case thing. I do like just the general thinking of like if you're asking a question like what is the average age of customers who bought an Xbox game controller in March, questions like that like I think you would always want to use an SQL system. I can't imagine like a semantic search LLM thing being the best answer to that particular kind of.
Right. Right.
So that's why when I love that text SQL topic, and then I like to say, Weaviate has an aggregate API. I don't know if maybe we could build a SQL API. I just don't know what even that would entail.
Yeah. Right. Right.
But it would
Yeah. I
interface.
mean,
Yeah. Sorry.
I mean, if you're if you're trying to get if you have a list of products and you're merely just trying to get the cheapest product or the most expensive product, then yeah, and a traditional SQL query will get you just fine, right? But if you're searching the product description and you're searching for if you're searching product description and you're searching for a product that lets you accomplish certain things, then yeah, I think a semantic search would be more suitable.
Mm-hmm. Yeah, I mean, I did like just when Mosaic was acquired by Databricks, I did a little more homework on like what is Databricks and what stuff like, and they brand themselves as like structured, unstructured, semi-structured data lake, and so I generally think this idea that like unstructured and structured, data schemas have more to learn from each other. I think semi-structured is where you like. I think like Snorkel AI is one of the pioneers of this idea of like programmatic labeling, where you like predict missing structure from your unstructured data, and yeah, just I think there's a lot. I think
Mm-hmm.
that's a super. How do you unify these things? I think that's one of the areas of innovation in these new kinds of databases.
Yeah, right, right. Yeah, and this problem, this dilemma has been around in software development for decades.
Yeah. Well, super cool. Andrei, thank you so much for joining the podcast. It's such a fun discussion. I think the Ruby client, hearing about the motivation behind it, this whole space, and the LangChain tool use, also interesting. Thank you so much.
Thank you, thank you. It was a pleasure. Thanks so much.